All right, so probably a lot of you know who I am, so I won't belabor the point. Can you guys see this nice and clearly back there? All right, so for the camera, hey, I'm Aaron Hilton. I am developing mixed reality technologies for fun and for hire. And I work with Occipital an awful lot. Jacob is in the crowd here. Kiddy Kong uses Bridge Engine to good effect. And so we'll get into that in just a moment. All right, so with that, I want to give out some really sincere shout outs. There's some people here in the audience. Shape Immersive is the company that's trying to do a new spin on the AR cloud using blockchain technology to encode your spatial map of the world around you and make it serviceable and available to anyone that has an infrastructure, a piece of technology that could use that map of the real world. So a digital double proxy of the real world. So that's why we worked on Kiddy Kong together. It's actually his idea. Immersive Tech with Jonathan Andrews, man, they do some sweet fabrication work. Incredible design. They are brilliant. Pen Sensory Interactive, I was super, super lucky to run into Ollie Rankin through the VRARA. It was an introduction through there. He was like, well, what do you need? And I said, well, you know, you're super high level, so just if you have anyone you know that could do this kind of thing with Kiddy Kong, which is the cat AI, it would be great if you could forward them my way. He comes back with, I was kind of thinking I would do it. This is a guy that worked on the crowd simulation with Weta for the Lord of the Rings. So like he's super skilled, super great to have him on board. Postal Audio, Chris McIntosh. I reached out to several of the audio crews in town. I really like Chris's style. He just came back to me with like, yeah, I mean, pretty limited budget that you got, but we can do a lot with that. So he sourced a lot of the sound effects and did a little bit of custom sound design. He's got an amazing studio here in Gastown, and he can do like the full everything. Like he can do the like whatever you can imagine that you would need for a sound work, he can do it. So and the Sawmill Crew. Now, Kiddy Kong wouldn't have been possible without the Sawmill. They are a how would I say it? Effects house. They do motion capture work, but their team also is flexible in doing all the keyframe animation work. And oh my God, you guys just got it together and did a great job. So Neil in the crowd, thank you, thank you. The rest of the team, Derek, he's the CEO. Ramiro is director of animation here. Brandon, Neil, Megan, Sarah, all a great crew, super fun to work with. So, thank you. And do we have contact? Yes, we do. It's not refreshing on here, though. Huh, all right. I'm just going to go off the screen here because it's more reliable. Right, so Alex and I kind of sat in a room and we're like, well, what can we do in this limited time frame? AWE, this is Augmented World Expo, is happening in T-minus 5 weeks. And we're starting from nothing to like something. And so, you know, we roughed out Kiddy Kong and what it would take to actually deliver this project. We're really at the high level. We're like, okay, well, we need to come up with a narrative and come up with all the primary elements. And we have to, at the same time, start recruiting people to actually do the work and start to like nail down the actual asset list and all the things that we're going to need for this. Wow. So when we started estimating out the timing, we were like, okay, and we have to concurrently do the physical fabrication and really hope if we nail everything together that we will get a finished result with a little bit of testing time at the end. Well, there was no room for error. So we roughed out this idea. So, you know, what if we had a large cat climbing a tower and we just kind of created this like Empire State Building, and it was a multiplayer experience. We really wanted to show off how a shared coordinate system, shared amongst devices, could create a multiplayer experience. If you're on the same coordinate system together, then you should be able to see each other in the play space, playing around, actually shooting the things, and have this kind of sense of shared presence with a digital experience. Little did I know, we were breaking some massive ground. So first off, when we started working on Kiddy Kong, every project that I do comes down to the user experience plan. It just has to be a simple paragraph, like just writing it down. Like, what is the flow? Picturing in your mind a movie of what a day in the life with this experience would be like. And it is so valuable because it helps map out exactly how everything's going to play out in your imagination. So we go through pre-start, okay, we're gonna rally up some participants, and we go through this kind of setup. We also had to think through like, oh my gosh, what if there's like no Wi-Fi? If the Wi-Fi was just like crashed or just unreachable or whatever, just jammed, which happens in large event spaces. So what's our plan B? Fortunately, we didn't have to do a plan B because we just didn't have time. So we just kind of cranked through it, and we did the experience. We worked through the game mechanics, basic how would you interact with Kiddy Kong? How do you shoot Kiddy Kong directly? Do you shoot at this? We came up with this idea of a barrier wall, and like, oh, maybe we just build that up. And we had a whole bunch of alternative game mechanics all kind of figured out, and we're still trying to figure out like, how do we get there to this like fun experience? And then we had to collect up lots of reference materials. Oh my God, the internet and cats. What could be better? So there's lots of reference material on the internet. Oh, that was the best part, sorry. No, oh well, too late. This cat does not succeed. You'll have to watch it on the internet sometime. Game mechanics. So we had to work out, what are the projectiles? What is the look and feel of the overall thing? Okay, so we were like, oh, maybe we have like kitty grenades, kitty minions that are like Kiddy Kong would throw at you, which is like super funny. And we're like, yeah, okay, sure. We looked at different types of shooting, projectiles. I don't know, who here has played Space Pirate Trainer? A few, yeah, okay. So the really neat thing about Space Pirate Trainer is that you have projectiles, laser beams that come and shoot towards you, and you're like, oh no, I'm gonna be hit. But then it goes into like slow-mo, and so you can kind of dodge or react. And so we're like thinking, maybe we do a little bit of that with the laser beams. We also had to represent, the things that you were shooting or that you were charging up. So we were like, okay, why don't we charge up a blockchain? Okay, we'll play on this word, yeah. Blockchains. We're charging blockchains. We're going to shoot at the wall, and we're going to build this barrier wall with blockchains, sure. And we were like, well, Sony's got a really good representation of players or the keys. Something that's very important that actually Sony takes into account in all of their game design and the console design is actually color blindness. So that's why the shapes plus color. So color is very easy for people that can see color. People that can't see and differentiate like red, green, that's where the shapes kick in. So shapes are much better. So we had a dominant shape for every player. And we're going to use this dominant shape throughout the game experience because we wanted, there's like, you'll see there is some planes overhead, maybe, if you like look carefully. They didn't actually get it fully implemented for the Kiddy Kong experience, but we were thinking that there'd be something to do with what the planes do. So there is something coming up that you may see the planes in action with, and you'll better understand why the shapes are so relevant. Right, so Kiddy Kong moves around a lot. Doing any sort of climbing against a surface and interaction requires a lot of linked coordinated animations. Fortunately, Unity's got some really wonderful animation linking capabilities, so you can do some animations, but there is still a lot of nuance to setting up a rig and using the root motion control in Unity's Mechanim system to tie it all together. There's a lot of animations, so there's a lot of planning that has to go into it. So huge props to the Sawmill and the crew there for breaking it all down. So I gave them, here's basically all the movements that I need, and then they looked at that and broke it down even further into how would all of these things actually link up and make it all work. So thank you, thank you. That was awesome. All right, parallel to this, we also had to figure out how do we make that thing over there come with us to Santa Clara. So it had to fit in a suitcase. And they have some funky rules around their unions, and therefore, if it took a screwdriver, generally you were going to be pestered about using union labor to do the assembly. So we were like, okay, it has to be assembled without a screwdriver. So we're just that cheap, but actually, union labor costs are insane. I don't care what they are saying. I'm like, you know, they only work this much time. I don't think it was right. There's like serious highway robbery going on down there. But okay, we can solve this. We can do it ourselves. We just pack it in, unload, start putting it together. And it has to be big enough that we could track on. So it couldn't be small. It had to be voluminous. All right. So we were like, okay, well, it's in the clouds. We'll make it just the top part and see what we can do. Jonathan came back with this amazing contraption. So it is a fully foldable design. All of the elements of this assembly collapse. There's a lot of like hidden ribs inside that are the hinge works that fold up, collapse down, and everything fits in a big suitcase. One suitcase, which is kind of a mind blow. It was too heavy for trying to get it through the on the flight, so we actually did divvy up some of the parts. But for the most part, we managed to pull it off. And yes, it does fit in a single suitcase. We also had to have the digital equivalent figured out because we had to develop all the animation work to fit with the physical finished shape before it was finished being built. So we had this design. It was really urgent. Come on, guys, we need this design. And they came up with the model, and then we were able to cross-check that all the dimensions were close enough that we could get all of the Kiddy Kong animations figured out and the layouts of exactly where Kiddy Kong is interacting and jumping to and all that sort of thing. So yes, finished model was exactly the same as the digital model. So awesome on Jonathan and crew. Jonathan did most of the fabrication work as well, and Shape Immersive text team. And then they vinyled it up. Okay, so animating Kiddy Kong. This is basically Sarah, Neil, working away, and the rest of the crew. They came up with they got a rig for a cat, and we're like, well, let's just check. Let's do some animation tests and find out. So their idea, they worked super hard on getting all of the proofing of how you would do all the basic animation work, proved it out, and we're like, okay, good to go. And pounded away on all the animations for the next, was it 2 weeks? That was it, just 2 weeks. That's all the time they had. And it was like, how many, 30 animations or so? 26? It was close to 30, I remember. Yeah, over 30 if you count all the in-betweens and pre-work and all the stuff you guys did. So yeah, amazing work. Thank you so much. It worked out. I tried using the Unity Editor XR. So I was like, I wonder if this Editor XR thing could actually be used for level building. So we wanted to create this barrier wall. And so I was thinking, okay, well, why don't I just make the component parts And I did this at the Sawmill, where I just kind of grab the components and I start arranging them. And I can build the play space just in VR. Just put the headset on, start putting the components down, and all the components are reactable and placeable. And so I can just clone them and size them and adjust it. It was an interesting experiment. But one thing I learned was that math can do it better. So when it came to building up the barrier wall generatively, this is actually a lot less work. By being able to figure out the math structure, I had to figure out, OK, well, how would I do a dome-like structure in a way that you can play and you can hit all the pieces, all the panels, and make it all just stitched together. And it's a honeycomb. And so the math for a honeycomb turns out to be fairly simple, but it's not everything not an everyday thing that you use. So you have to figure out the circular radius and the offsets along the lateral and the vertical. And the vertical is actually just a portions. Oh my gosh, geometry. All that high school math really meant something. But yes, I did figure it all out. It worked out the equations and created a generative thing. It was a lot easier than hand editing the level loading, which led me to just say, I just want to pick this this size of barrier panel, and it would just auto-generate that for that size. And it let us scale the play complexity to deal with multiple players. So the more players join the game, the smaller the panels, and the more of them that you have to get. It's directly proportional to the number of players. Unfortunately, there's a little psychological gotcha. When you have more than one player, say 2 players, 3 players, you get more and more variance of skill, but a narrowing, so this is a statistical modeling, narrowing of what they could achieve. And that narrowing actually went into impossible to win territory. So by 4 people, sure, is a directly proportional number of barriers. If they were all trained up and totally on it, they could win. But it was, if it was a new influx of people, it didn't actually work out. So turns out you got to play test this thing pretty strongly with a crowd to find out just how that actually works in practice. So OK, so when we set up for a mixed reality fixed installation, you have to align it. So this is how we came up with alignment here, is that using the bridge remote, we're able to place the key points of the digital model and actually have it intersect with the mixed reality scan, which is really fun because you can see how precisely aligned you actually have it or not. And we physically push and pull it into alignment. And you can either, you just grab and then rotate. There's me every time I pull the trigger, I'm also shooting one of the blockchain projectile things. That's because the game is actually actively running while we're trying to align it. It really is just a hack to do the alignment. But every step of the way of the alignment lets me visually verify that, yes, I have precise alignment and that this is now set up. Once it's done, I can just turn off the remote and just play the game. We just play the game on the iPad. So that is basically it. So Kiddy Kong came together in 4 weeks and worked out pretty good. People actually generally enjoyed it. So the big takeaways here is that a shared coordinate system where you have multiple people playing, it works. Unity's networking model, it works. It's actually fairly easy to figure it out and set it up. I actually knew nothing about Unity multiplayer networking other than I took a little workshop. So I did it once. But I learned a lot on how to do the multiplayer networking. It's impressively simple, what Unity does for you. And so it made a really fun gaming experience. People are able to build this barrier wall and play around. And the development of it was actually fairly straightforward because Bridge Engine lets you do a scan. So we actually did a scan of the fabricated model, but we could do that. We could also have just the digital model. We just created most of the game experience in Unity's general editing system, and only when we're ready to actually test on, it was really late in the game where we actually started doing testing. The hardest thing with a multiplayer thing was actually dealing with the coordinate system on the server. So what we had to build on the server side, what we had to build on the server side was a kind of a proxy understanding of where the world was. So once you do that alignment calibration, where you replace the digital proxy, and then you connect to the server will ask the first client that connects to it, hey, where is your stuff? And then the server goes, OK, now I got it. Now I can tell everybody else that joins where that stuff is. And that means that the server doesn't have to sync up. It doesn't have to be rebuilt with a new map of the space. The server can be built once, and then the clients can just do the setup and then connect to the server, and the server gets the new setup. That was the one really tricky thing to figure out, was how to get all the coordinate systems to match on everything, all the clients and the server, and get that working. It was one of those things where I've never done this before, but actually completely skipped a night of sleep. Completely, never, did not go to bed. And then held out the entire day at the first day of AWE. And pure adrenaline. Oh my gosh, just pure adrenaline. Held me all the way through. People were like, you're still alive? Yeah, which is weird. I'm OK. But I was out after that when I got back. So yeah, that's basically it. I hope you enjoyed the talk. I bet you have tons of questions. So feel free to whatever's in your mind. Just in the interest of time, some stuff I didn't go into, but I'm willing to go into. The front end and leaderboard user interface development. That was really fast. My experience using UniRX, where it was great, where it fell down with the network sync var. And also just how we built a custom bootstrap for Bridge Engine. So starting up Unity, we actually use our own bootstrapping for so that we can go directly into the experience. So you can fire away any of those questions too.
Were you the only developer working on this?
It was Ollie and me. So Ollie worked on most of the Kitty Kong brain and the plane brain, and also all of the animation linkages. He knows Maya inside out and backwards. So he was able to write a lot of the automation to bring in 30-ish animations, or 26-ish animations, the finals, and restructure the skeleton data and do a refresh export to fit within our needs to actually make it work. Without Ollie, this wouldn't have come together either. So it was literally everybody pulled like crazy on this project. And if any of the people got sick or just couldn't pull what they were doing, we wouldn't have finished this project in time. It was that right down to the wire.
It's in 5 weeks.
5 weeks total from the first conception phase. About 4 weeks was our actual dev time. Yeah, it was crazy.
What's your next iteration after this? Are you doing something that builds on this? What you've learned?
I can't talk about it yet, but I can say that Kitty Kong will live on. Yeah.
What about the first iteration, right? The Kenyan. What changed between those?
Oh yeah. OK. So if you look back there, there is this canyon fabrication. So Immersive Tech also built that. That was a collaboration with myself, Nano 3 Labs. And it was spearheaded by Alex from Shape Immersive as well. So it was the precursor to Kitty Kong. The idea there was very simple. We have this technology with Bridge Engine hitting 1.0. Why don't we show the world like what mixed reality is in a really interesting way? So we designed up, we were like, okay, well, how do we represent mixed reality? Well, occlusions, shadows, all these things. Okay, won't we build a prop that showcases this kind of thing? So that's what they built. Is this canyon. So we created like a little digital scene of like this thing playing out, this little space battle. And so we put that together, and we had this opportunity to show it at TED. Not on the stage, but it was a exclusive VIP showpiece in the back that they got to come out and check it all out. And so it was really amazing. We got to meet and greet and chat with like so many of the like amazing speakers of TED in person, and show them our technology. And one of the shining moments to me was like the guy that like was the founder of like the internet, and his involvement with VR and some of the stuff he had done. I forget his name offhand. I don't know if you guys saw his talk. He talked about like Facebook and like an alternative business model at TED, a for-pay business model that is better with user privacy and user data. Anyways, he was there, and he was really blown away by the whole experience, and that was like amazing to get his kudos. So, yeah.
So did you use Photon or just the built-in networking?
Used which?
Did you use Photon or any other plugins for the networking, or was it just the initial?
Pretty much core Unity networking. Yeah. What I was trying to achieve was actually using data replication with UniRX. UniRX is a reactive extension for Unity to let you define a set of data that are like your reactive properties, and then everything can subscribe or create like components that have observers to that data. I've used this in the past with my other company, Conquer Mobile, for the Periopsin product. What was really interesting about that build out was it, because your code is structured in a way that is very deterministic, it's very clear what the relationships are. When you build a Unity object, then it's completely self-contained. So it's taking object-oriented programming to a whole new level with reactive concepts. So you create this little package. You could like create a clock, and the clock has an observer of time, and then you just hook up the time to the clock, and the clock will represent the time. Makes sense, right? But it's actually kind of amazing how people don't know about how to reduce these variant states across their application. And statefulness in an application is your like worst nightmare when you're trying to deal with like especially like a multi-user game or whatever. You're dealing with like lots of variables, lots of things going on concurrently. If you have a lot of states and it's not well managed, you'll run into a lot of bugs. And those bugs get exponentially harder to debug. So eventually your application development just grinds to a halt because you're just wrangling with bugs and you don't know where they're coming from and you don't know how to like fix it. But if you make everything completely deterministic, reactive to their state, then the domain of like what you're trying to figure out is really tightly defined. You're just working on this one little piece. And you know that that one piece is working properly. And then you can like work on, okay, so you can determine, yes, that's working fine. Now you can go, okay, well, if that piece isn't working, but it by itself is working, then you know what's connected to it is maybe something you need to work on. And so in terms of debugging that kind of thing, debugging a reactive system is much easier because you can trace exactly where you need to look, very easily. But there are still like issues with reactive programming that you still have to like work your way through. So I wanted to use UniRX with the networking, but unfortunately, Unity's sync vars, they are kind of reactive variables. You can hook up observers to them, but it's not nearly as powerful. And they are unfortunately not integrated into UniRX, or UniRX isn't integrated to using sync vars. So it's unfortunate that that's the way it is. I am tempted to engineer in sync var support into UniRX so that you can just simplify all that, how your code works. Someday, when I have spare time. Who has that? Anyways, yeah. Anyone else? Tim Berners-Lee. He's the inventor of World Wide Web, but no, not that guy. But yeah, it was another guy. He like had dreadlocks. He was sitting in a chair and he was talking. Jaron Lear. That's Jerome. Jared Linear. That sounds about right. That does sound like the guy. He was there in the back room. He was like, yeah. What was it?
So Jaron Lanier is his name, and he has a book called Dawn of the New Everything.
Dawn of the New Everything.
Yeah, so he talks about when they created the concept for virtual reality. Back in the 80s.
Yeah, in the 80s was kind of when he was doing his thing. Pretty interesting guy. It was neat to have him like check out that Ted Canyon experience and go, wow, this is really cool. Having that kind of reaction out of a guy that was like, so like such a future thinker, to actually go, this sci-fi thing is getting real, was really rewarding. Yeah. Oh yeah. So at AWE, when we showed it, I thought I'd go hunting around for who else was doing a mobile mixed reality thing that incorporated all the elements. Multiplayer, has shared coordinate system, full-on mixed reality, self-contained. Nobody else. Everyone else is doing augmented reality. Some people are doing some shared coordinate stuff. Some people are even pulling up multiplayer. Meta 2s are pretty interesting. But nobody was actually pulling it all together. So that was really rewarding to actually be like, oh my God, we're actually the first. Unfortunately, we didn't celebrate it loud enough. So nobody really knows that we actually kind of broke ground there. But we actually pulled off the first fully contained everything. So. All right, guys, thanks for coming.